Okay, so I guess my Britney Spears cluster is gone, right? So MNN. Okay, I'm just going to make another one. So you can take, a few seconds to a couple of minutes, depending on. So while that's loading, let me give you some other information that people here are interested in. So, for example, there was a question that, this is sort of the main page, and here's plan of action. But remember, I'm trying to dynamically deliver this content, which means I need to see how you guys absorb it and do a cut at 5 p.m., right? So the content we uploaded through this DVC archive is usually a superset of what we will be covering, right? That's what I did. So usually this kind of orange signal means I'm kind of in the middle of changing stuff. So this is the plan of action in progress. It has basic logistics stuff here. Databricks login, which you guys all know. And please RSVP at the meetup before you come, because one fika is 38 crowns per person. So we kind of are reaching budget limits and we don't want to waste stuff. So anyway, the other main thing is this stuff is in progress because I literally finished it this morning. And for example, for next Thursday's meeting, there is a bit more of outline because it involves Simon Lindgren from Umeå. So he's a digital sociology professor. So he's going to be our domain expert, guiding us on what is digital sociology. And he'll be covering digital ethnographic or digital sociological work on the Me Too movement, which some of you probably know about. And then we'll have a break, and Amelia Andersdotter, who is also a student of the course, but we have a couple students who are also instructors for parts of the modules where they're better than me, so we learn from students. So Amelia really knows a lot about law. I think she's studying law as well. So she'll be talking about data protection, where does it come from, GDPR, ethics for scientists, and so on. I will try to cover some other things that I think are very important. Again, I'm just going to leave 2 pointers for you to get into in detail later. So I'll probably talk about this particular EU law to fight online hate speech. It's tied to xenophobia and some other EU charters. And I'll talk about toothlessness of something called the right to an explanation for automated decision procedures. I'll mostly just point you to papers in Oxford Internet Institute and other experts. But these are very interesting problems that are currently being debated because law is really, kind of behind a lot of this technology. And for Thursday, there is actually assigned viewing. So it's about 1 hour. It's preparation. So usually in the POA, if there is something in bold called preparation, then please do this. It's like preparing for this. So I would like if you spend about an hour to mindfully watch the assigned viewings below. So this one's a 20-minute video by Kathy O'Neill, who's the author of this really interesting book called Weapons of Math Destruction. So it's about mathematical bias and models and all sorts of very interesting mathematical model auditing and things like this. And then Bruce Schneier has written this beautiful book called Data and Goliath. Of course, I should read these books, but at least I'll assume you'll watch this 40 minutes long talk he gave in 2015 at Google Talks. I have no way of checking you have, but my lectures will assume you have watched it and understood it, because we don't have time to get into everything in our allotted. there's a few other things, but this basically gives you the context post-Snowden revelation on what sort of happened from the US point of view. And then this can be, so this stuff can be seen as a EU's reaction in some sense to some of this stuff. Okay, and then we'll have lunch, and then Simon will be showing you how he did this Me Too movement digital sociological study by sort of showing you what he did in some Jupyter environments on Python, non-distributed setting, and let's just hang out and watch what he's doing. And then I don't know when he's going to stop, maybe not the whole 90 minutes, and then I guess I will try to get into the quintessential data set for digital history or digital humanities called the Old Bailey Online, which is an incredible data set of the so-called English civilizing process. This is every single court case in London's Old Bailey since 1673 to 1910, completely written, transcribed as XML documents, who said what, when, what was the defendant accused of, what did the lawyer say, all the details, right? So we will dive into this, and in fact, you can make very nice and elegant, simple mathematical models of the evolution of English law itself, right? We can test hypotheses. So I'll try to, do a kind of a lecture, less coding on this. And my main goal here is to show that we need to fuse what's called inferential thinking, which is traditionally what's called statistics and probability. This is about a 300-year-old tradition in the world, and the idea is the sort of so-called data science revolution is about fusing this kind of inferential evidence-based thinking with computational thinking and distributed computing at scale. And I will try to illustrate this sort of style, right? And it's a style that a lot of famous people, Berkeley and Stanford, also say is the right way. I just watched some videos from them. So anyway, that's important, right? So we're not just interested in engineering and processing data at scale to do certain manipulations online to increase profit. We need to be accountable for the implicit or explicit biases in these models, how it affects people, what is the societal cost of our algorithms. So there's a lot of ethical issues. And I will try to pack all this in like 90 minutes, okay? So, but it's just a pointer. And then these other things are currently still being formed. What will happen in the second day? I most likely will try to empower each one of you to be your own mathematical statistical experimenter in the Twitterverse. So you should get your own Twitter API credentials and go and collect data on whoever you like after having heard what the laws are, right? So the idea is to completely democratize monitoring, okay? So this is one way forward. And I think it'll be fun. But to prepare you for that, I have to get into the Spark streaming library. Remember, that was one of the three main libraries. So we will start learning about this particular way of doing Spark streaming. And then some of the code is written already, so you don't have to worry about the details. But you can now start collecting Twitter data from the public streams on anyone you like. So you can specify Donald Trump or whoever you want, and it'll automatically start collecting. It's all free. Of course, you have to use your own Twitter credentials. You're not going to use mine. And it's fine. And just don't hit that publish button in Databricks notebook, which there's a public publish button that'll publish your notebook publicly. Don't do that. But just see what is going on yourself, right? So we'll do a lot more. We'll do a bit more sentiment analysis in LP. So I will sort of customize Friday on what Simon actually gets to do on Thursday. So that's kind of the plan. I think Simon plans to do, currently he's planning to do topic modeling, which is sort of grouping tweets by topics. And then I think he wants to use the streaming API in Twitter so that not only can you track individuals, but also track by keywords and hashtags. So we can do that as well at scale. So everything he's doing is non-distributed and we'll do distributed. And then I think he also wants to do some kind of sentiment analysis. So we'll maybe introduce logistic regression via sentiment analysis, okay? I don't think it's ambitious, but I think we can do it. Then May 3rd is on geospatial analytics and big data, so we're still formulating it. I think here the first 90 minutes will be by domain experts, John and Marina in the back there, from geography, cultural geography. So we'll talk about different data sets, what are problems of interest, how can you improve urban planning, blah, blah, blah. So that'll be really good. So we know what the problems are. And then we will sort of slowly get into various things. And okay, so right now all we know is maybe there'll be fika. We may be running out of money for kannal bunnar and klad kakka, so it'll just be coffee. I'll try to buy, you know, what do you call them? Breads from bakery. It's a lot cheaper. So if you want, just bring something, you know. But I'll try to make sure there's coffee at least. So one other correction is on this one, by the way, is the 3-day module on mathematical, statistical, and computational foundations for data scientists. This is kind of reverse engineered from this course I taught last semester when I found that there was a lot of basic information a lot of the PhD students were missing, but they could easily get. So this is kind of a reverse engineering of the prerequisites, I think. And it's sort of building on top of this very popular course called data8.org, which is the fastest growing course at Berkeley, 1,000 students per semester. It's a freshman course. So I'm basically giving a mathematically tighter version of this one. So we will heavily reference into that. So this is basically the idea of computational thinking plus inferential thinking is data science. And what's the style here? The style here, I don't know. So I should probably say a little bit, right? So I'm going to, you know, we're going to do proper maths, not scary maths, but like I said, you only need high school algebra, high school maths proficiency. You just have to be slightly stubborn, but we're going to actually study number systems. You know, it's a lot of embeds into Wikipedia, so that when you see these symbols, you shouldn't be scared in like a basic, you know, textbook on machine learning, like say machine learning from a probabilistic perspective, like Kevin Murphy. It's a really good book. So my goal is to prepare students who finish all these three to be able to read a pretty decent textbook for beginning graduate students in machine learning, for example. So yeah, and it uses Python and SageMath in particular. So we basically, you know, we will actually learn things and do things as so we'll learn the math concepts. Okay, you have to forget about Scala at this point. We'll just only do Python now. But you'll learn about Python and SageMath and so on. So we will do things very slowly. So sort of numbers, strings, booleans, functions, maps, collections, probability, conditional probability. So everything will be developed axiomatically. There won't be measure theory, but you know, it's so the idea is yeah, we will do modular arithmetics and implement our own pseudo-random numbers, and so you really understand what is a random number in a computer and things like this. So anyway, I haven't finished the list; it'll keep growing, but that's basically the plan. Oh yes, and this is a plan change on 5. So this used to be a two-day module, but it's now changed to 1 day. Just because life is short, it's a scheduling issue, and I'll explain why. So it's going to be just on May 31, and it will be just the first half will be the sort of theory of population genetics we need, the minimal theory, and then the second half will be doing this 1,000 human genomes on Hale probably. So we will sort of apply this basic pop gen theory, which itself will build on this. Remember, this is a prerequisite for this course. So we will already start seeing random graphs and things like that here that are relevant for population genetics. Then the final course is, this is just a Blackboard lecture. So a lot of people have registered for it. You're welcome to come. But it's just pure maths. Like I'm just writing on the Blackboard for, you know, 360 minutes. So it's just L1 theory. It's a very strange and beautiful school of density estimation. So you know, yeah, that's kind of the plan. Okay.
Will all of these be available on YouTube as well?
Yeah, you know, up to technical issues, right? Yeah, I think. Am I okay now on YouTube? Or? All right. So, yeah, Chrome restarting is like the key, right? So what should I say? Marina had a question, so she wanted to know why, I guess, It's a good question. So why, if I go here, and I hit this link, it doesn't work? It's by design, because tonight, you know, after enough tequila or whatever, I'll relax. I will take the content that we have stably created and put the right files here. So this will be the archiving process. And also the YouTube videos will be archived by then, okay? Then I will embed those videos in here. So I want to do this meaningfully for you guys. Otherwise, I don't want to force feed you guys, okay? So yeah, so please follow the DBC archive route that I showed you, which means you always go here. So this will take you to the GitHub repo, and you always go to DBC archives, right? And then in here you go to 2018, and I will put the latest files here. This one's just Scalable, but you know, so you will see anytime I change anything here, I'll just update this, okay? What else are we missing? Right, and Amin wanted to know something else, which I think is very interesting and important. So you can go to the URL from this way. So if you go to this course that finished last semester, there's a lot, you know, of other stuff. So your stuff on infrastructure, right? So as I said, we're doing this course in the cloud because it's convenient, but of course you may not want to do this in a managed cluster in the cloud like Databricks. Maybe you want to just get your laptop ready. So if you want to just do this because, you know, I don't know, you're in transit and you want to play around with these notebooks locally on your machine, then of course you can do this, but then you need to, you know, how to work with Spark on a local computer, and you know, so you can. We're doing the cloud full version here, but we can do the cloud free version. For that, you need to set up Docker, and there's, you know, operating system specific steps, and it gets involved, and it's kind of not. If you know this, you already know it. If you don't, it's going to take all. There's a whole course on this, 2 courses on this in the IT department, so you should really do those courses. But it's all here, okay? So for example, I have a Docker image, SDS, and there's a Docker file for this if you know what all this means. And sort of, there's a heavyweight Spark Docker and a lightweight and a Zeppelin Spark Docker. And so all these are, if you know what these Docker files are, okay, these are all done in detail, so you can just rip this and whatever, get into it if you want. So there's more than that. We also have, you know, so if you're more of a software engineer, you would probably want to work in an IntelliJ, the integrated developer environment. If you're a much more low-level type, like you may want to just do it with the Scala IDE. Oh, sorry, this is another GUI thing. But if you are like VI guy or whatever, like Atom, just text editor, then you want to do command line using a simple build tool. So all these links will take you further for data engineering scientists to really, you know, get their feet dirty, right? So, and then there is a lot more than that. That's only on your local computer. So if you want to actually start doing the same thing on an on-premise cluster, which Don and Tilo helped build, it's sort of sitting on my desk upstairs. So it's just a 3-node new cluster. So this is called Intel Next Unit of Computing. Right, so these are tiny little computers. They're quite powerful. They're cheap. They're really this big. So you can stack them on top of each other, and each one can hold up to a terabyte or 1.5, terabytes of hard disk. And you can put up to 32 or 64, I don't know, gigs of RAM. So you can actually have just a bunch of them, you know, process like 20 terabytes of data or something, right? So that's really kind of no way out if you're analyzing some sensitive government data on citizens, for example, right? Say some non-confidentialized data on Swedish, sorry, what is the agency in Sweden?
SCB?
Yeah, SCB, the Statistics Central Bureau.
Yeah,
Central.
exactly.
Yeah, right. So, and I think some like the geography guys work with these kinds of data sets. Then you need to have this kind of on-prem cluster. Same for health data, like École Polytechnique, there are groups that are sort of doing the same thing for French Ministry of Health, like data fusion. So they do all of this in on-prem clusters. So to do that, again, we have done some work there. So this is Alexei, who was here but had to go back to work from Combiont. He started us off on automating private bare metal Intel Nuke cluster setup with Cobbler, so like all the steps on starting from networking and how to go all the way up. So Emin, you might want to get into this, and we can maybe meet next week. So it has everything about switches and networking and so on, and it has all these various steps. So and then there is something Dan did, which is like if you have sysadmins and don't give you root access to a bunch of Linux clusters, then you can how to install Spark, Hadoop, Yarn, Hive, and Zeppelin without root access. So this is Dan doing some meetup. Let's see, Dan. Oh, I have two likes, 64 views. So anyway, he talks about how to do this in detail.
But
right?
you have to set it explicitly because of the network configuration of the Hadoop stuff.
It's not. It's there. Sorry. I just want to kind of dive into these things because don't think that I'm just selling you Databricks. We just kind of are in a hurry. Okay, so yeah, this is this is also very useful if you have access to a Linux cluster but have no admin rights. And then this is the latest one. So this is Benny Avlin, who's another data engineering scientist at Combiont, and he sort of went through these other tutorials, and then he has one bash script for doing the whole thing. So if you like bash, you can just go all out. So this is, again, another way. Once the networking is set up and the operating systems are installed, you can use this bash script. Right? So what is the other thing, I guess, the minor thing is if you start your own cluster, you cannot run Databricks notebooks on your own cluster, right? So then you probably still want to do data science and interact and have a nice notebook environment. So to do that, there is a way. It's Zeppelin, right? So Zeppelin is an Apache project. Zeppelin. Yeah. Led Zeppelin? No. Yeah, Apache Zeppelin. I just was curious. Okay, so yeah, this is basically, it's quite beautiful. I kind of prefer this slightly more than Jupyter, but I don't really care. But there are if you guys are interested, let me know. There is a way to babble into Zeppelin. This is, again, something Don and Tilo have been working on. So we can go from all the Databricks notebooks we have directly into Zeppelin notebooks. There is a primitive version that works already. But then the problem is when you have Databricks file system and you're mounting files in this DBFS specific way, then it gets into problems. But that's inevitable because the underlying file system will be different here, right? Because here it'll be a Hadoop cluster that's running on your own on-prem thingy. So some things will not work, but most of the code will work.
The notebooks we're using now, is it Zeppelin notebooks?
No, it's all Databricks, but I guess I'm just kind of telling you like there's a lot more going on. So because I'm kind of looking for people to help at some point. Oh, well, help, but so I'll show you what I mean. So I think it's maybe it's ZP for Zeppelin, yeah. So this is just the Git repo that you guys are looking at. So if I do ls2, I mean, I haven't pushed this, but basically these are the Zeppelin notebooks of the Databricks notebooks that are publicly available. So if you want, I can push this, but please don't bug me if a cell doesn't work, because you can go and figure it out and fix it, right? You have to start contributing to Pinot. But it's way faster than just copy pasting each cell. That'll really hurt your finger. So almost everything works. Yeah. So I mean, the only things that don't work are like display HTML, because that's a specific Databricks specific display function. But then now Don has written something that allows you to kind of work. Okay, so that's kind of a landscape, right? Okay, so let me get back to M&M rules is ready. So where were we? Here? Okay. So
No,
here?
number 6, I think. We
Oh, we're
reached
6. Okay, thanks.
reduce.
Yeah. Filter, map. Okay, so yeah, and this is what I was playing with. Yeah. And I think, am I right? No. What was I doing? Yeah, this is right. And then this was collect, right? Sorry, guys. I'm just, yeah. Okay, so the next action we want is reduce. And so this is basically reduce in a picture. So we essentially aggregate all the elements of the RDD by applying this pairwise function, which is usually the reduce function. So we apply some operation pairwise to elements, and then the output of that gets applied to the next element as a pair, and so on. So here we have so here we have an array 1, 2, 3, 4. We turned into a parallel collections RDD X, and then we just do addition. Okay, so 1 plus 2 plus 3 plus 4 is 10. But this is completely at scale now, so I can just print it, and that looks good. So that's a very very nice action. Reduce is an action. So flat map is very powerful because now it allows us to so this is kind of the picture. We have an RDD X with a partition, and so the main idea now is that the flat map operation will take in as opposed to a map which takes an element and produces its mapping, some other element. A flat map can take an element and produce a sequence, okay, of things it maps to. So it's a very powerful idea, right? So it's a one-to-many mapping, and that's basically what's sort of explained here. So let's look at this example. We have X as a array 1, 2, 3, and then we are applying flat map to X. And see what's inside the closure. The closure takes each element n, okay, because my RDD is now called X. So it takes some element n in it, and then it converts into an array of n multiplied by 100, and the number 42, right? Is that the answer to the?
Yeah.
Yeah. Right, so which means 1 is going to be 142 in array, and 2 will be 242, and 3 will be 342. So that means each element is getting it's flat mapped to 3 things, right? So it's a one-to-many map. It's very powerful. And you can, for example, take a line, in a textbook, and then break it by white spaces and produce an array of words, or take that line and do other things to it. So it's a very natural operation we'll start using very quickly. Now, this is our next key object. It's called pair RDD. So it's essentially an RDD of key and value pairs, right? So here is an example. So say I take I make this val called words, which is an RDD of this array consisting of strings A, B, A, B, B, A, B, B, and then I just collect the words, okay, which will return back to the driver an array of the string. Okay, so now I have words as my parallel collection RDD. Now what I want to do is make a pair RDD called word count pair RDD. Okay, so all I'm going to do is take words and do the map, and I'm going to map each word S to S, 1. We've done this before, so that's nothing. It's just a map. So now we have a string and an int, and this is key value RDD. So now we're going to perform some transformations on this pair RDD, and the first transformation will be reduced by key. So this is kind of the magical thingy, right? So instead of just reduce, where we just add everything, we now have to somehow reduce only the entries corresponding to the same, that have the same key. So it's like word count. And then we can do other transformations like sort by key or group by key. And we'll kind of look at the differences a little bit. So here's reduce by key in a picture. So we have this. This is actually what we made, A1, B1, and so in reduce by key, it's going to first apply this within the partition, right? So, well, there's only one A and one B, so there's not much going on after you reduce by key inside that partition. But in this partition, there are two A's and two B's, so you get A2 and B2 within that partition, right? So in here, three A's and B2. So you first do the reduce by key per partition, and then now you have to start shuffling them, right? So you're going to send these things together into, into here, where all the A's are together and all the B's are together. So this is where shuffling happens, okay? That's kind of the basic idea of reduce by key. So there is always going to be some network traffic. So this is, not a narrow transformation, right? Because it's a wide transformation. Okay. So that's what we're doing here. Word count pairs RDD. We call the method .reduce by key, and then we give it this syntax, right? So it's saying, because it knows it's going to reduce by key, you don't have to tell anything about the key. You just have to say what needs to be done to the value. So you're just saying, if for value 1, value 2, add value 1 to value 2. Or with placeholder notation, you can do that. So that's all this is, right? So you've basically done your word count, right? This is kind of the hello world of big data. So now the next one is just the same. I'm showing you the same.
Implicitly, the first item in the tuple is the key, or is it always the case? Because when you do reduce by key, it's going to take the first item as key, or could you specify that?
No, yeah, the first item will be key by default. Yeah, but then because it's a tuple, a Scala tuple, so you haven't gotten into data structure types yet, but you can do a mapping that flips the order of key and value, and you can make the value the key for that particular transformation. But the first one is default key.
What could I specify? So is the second item instead if I have the reversed order of?
Yeah, that's what I said. Yeah, so you can do map and then switch the order. You can, do k, v equal colon v, k, and now v becomes k for that. Yeah. I don't think we're gonna do anything like that. Maybe. Yeah, I don't know. Yeah, but that's a good question. Yeah, maybe I'm wrong, but you can do this. I think I'm right. I've done that before at some point. So this is just the same, right? I'm just using placeholder syntax because this is quite cute because you can just underscore plus underscore and.
So if you feed in a huge text, you can get how many times each word is.
Yeah, exactly. So now we can.
In one line.
Yeah, in one line. This is the exact same line. So we will do something soon like this for the US president's addresses. We can also download, text from this website, Nuremberg project or something. So you can get any book that's printed before 1923, and do all of this. The exact same code will work. Okay, so here's, you basically, now I'm applying something called sort by key. which is going to make a new RDD that consists of the elements of the original pair RDD, but these are now sorted by key. So this is very nice if you want to, so now let's collect it and bring it as an array to the driver. So that's our word count pair RDD, and then this is our word count pair RDD sorted by key after collection. So here you see it's lexicographically sorted by A's following B's. Preceding B's. Okay. So of course these are wider transformations because now data has to flow a lot. So the next one is important, but it's something you don't want to really use unless you really know what you're doing. It's called group by key. So when we apply the group by key transformation to this word count pair RDD, we end up with a new RDD that contains two elements. The first element is the tuple B and an iterable compact buffer. Okay, so this is a Scala collection that's very useful for keeping track of things. So what this compact buffer allows us to do is it helps us basically keep track. Let's look at the picture here. So basically I have the same thing, A's and B's. So now what I want to do is my group by key will bring all the key elements with A in them in one place, and all the key elements with B in them in one place. Right? And the iterable compact buffer is the thing that keeps this thing. So as you can imagine, this can be bad and dangerous, right? If your key is like so big, there's so many A's, like Patels in New York City beat Smiths now, right? So these are some Guju Indians, right? Gujarati Indians. Anyway, so it depends on what the key is, right? If the key is like really a lot, then group by key may really make the partition to, it could crash the driver as well, and it's very network traffic heavy. But again, group by key can be very useful for certain kinds of operations. And I think this is a very wide example of a very wide transformation. So yeah, so if you see what's inside the word count pair RDD group by key, and after you collect, what you get is an array of a string and an iterable int, and it's simply telling me this key A has these many values associated with it. Okay, so now the question is, where is the cluster where in the cluster is your computation running, right? So let's see. So if I do val list 1 to 10, and then I create a variable called sum, initialize it to 0, and then I simply map this way, right? I map x to sum equals sum plus x and print sum. I'm going to get 55. Okay, and if I now declare an RDD to be parallelized from 1 to 10, and then I say my var sum equals 0. Okay. So now I'm going to get sum is 0 here. So when I do this one, val RDD1 RDD map. So what I'm trying to show here is that for different places in the closure where the variable occurs, they're accessible in different ways. So here's my. So now I have created this val RDD1. So here it takes my RDD, right? So remember RDD is just yeah. So you don't have to always do this. So this is just my 1 through 10, right? So now I'm mapping each element here to sum equals sum plus x, right? And so what it's gonna, it's somehow, it's creating an RDD of type units. And if I actually ask what's in RDD1, I actually have absolutely nothing, okay? Now contrast this to the following. So here I do RDD1 as a RDD.map x, but look at the closure. So I actually am having a closure and saying var sum is 0, everything else is the same, and I'm returning sum. So now this thing is getting, shipped. And now if I actually do RDD1.collect, I actually get the following, okay? Because every time in this loop, sum is declared to be 0, and I'm only taking each x and adding 0 to x and reassigning sum to basically x, and then giving back the sum, which is still x, right? So what's happening in this closure is this thing gets packed. This variable gets packed, it's sent in, it's available in each of the mapping operations at all the partitions. So each x basically comes back as x, and we get our RDD1 like this. And if we contrast it with here, you see there is no closure, there is no, sum is not getting shipped anywhere. So you basically you're starting to return units. So I mean, we'll see an example of this very soon in a more concrete instance where we will use Google JSON classes inside this closure. But this is something to be aware of, and then if you want to, the other thing you guys should look at, should know about is this. So if you go to clusters. Let's open this in a new tab. So we have a couple tabs. So now let's look at Spark UI. Where's that? Spark UI, user interface. So now this is kind of where you would start exploring to see what's going on in the cluster. Right? So, and of course, I haven't told you too much about what are jobs and stages and so on and so forth, but it's okay. We can kind of get an idea. So, so you see everything I'm running, like RDD1.collect. There's a description of it, when it was submitted, how many succeeded out of total, and and you can kind of get more into the details to make it a bit smaller. So you can look at the event timeline. You can see what are the various, when was the executor driver added. I mean, there's a lot of details going on. Okay, so these are all the logs that are coming out of Spark cluster. So anyway, don't worry too much about this. We sort of will have to descend into this. You can look at storage. You can look at your RDD. If you use something later which is called cache, so you can cache the RDD, so it's in the distributed random access memory of lots of machines. You can go here and ask. We don't really have anything here cached, so you can see what's there. It's environmental variables, and when we run Spark streaming jobs, there will be a streaming button here. So we'll kind of jump into this. This is the Spark cluster UI for the master. Yeah, so as you can see, yeah, it's a lot of details. Okay, so that's kind of, let's see. Yeah, so that's kind of the easy stuff. Sort of the list is also easy, but that's like the basic stuff. So now we're going to start getting into what it means to ship closures, and what are broadcast variables and accumulator variables. So these are fundamental programming primitives in in Apache Spark beyond RDD. So let's see, we should maybe, yeah, so let's watch this AJ's video. It's only 2 minutes.
Spark automatically creates closures for functions that run on RDDs that workers, and for any global variables that are used by those workers. And one closure for worker is set in every task, and there is no communication between the workers. And any changes that you make to the global variables that are at the workers are not sent to the driver or to other workers. Now consider the following use cases. What if we have an iterative or a single job that has a large global variable? So this would result in sending a large read-only lookup table to the workers, or sending a large feature vector and machine learning algorithm to the workers. Or what if we want to count events that occur during job execution? So for example, how many input lines were blank, or how many input records were corrupt? The problem we have is that these closures that are automatically created are sent or resent with every job. So for an iterative job with a large global variable, we'll be sending that large global variable with every single job. Every single.
So to contrast, right, the little closure example I gave where we passed in var sum equals 0 and all of that, that's an example of a closure where the memory overhead is very tiny, right? It was just you know, an integer variable, right? And so of course he's talking about when you want to send, you know, do something like that to something really big, some really big object. For example, if our ambition is to get to doing map matching of GPS trajectories of cell phones on the second day of geospatial analytics module, and for that, if you're successful, we will be actually shipping closures of these huge monster contraction hierarchies of this graph hopper C++ or Java class thingy. We don't want to send that for every single OpenStreetMap way, you know, way ID and things like this. So then you have to do something more clever, and that's so you probably have to broadcast that to all the executors. So this really super duper object is sitting there ready to be served locally to all the partitions there. You see, that's kind of the, so there is a big connection to what we hope to do here.
It's also very inefficient to continually send large amounts of data to each worker. And closures are one way from the driver to the worker. So how can we count events that occur at a worker and communicate that back to the driver? Well, to do this, PySpark provides shared variables in two different types. The first is broadcast variables. These enable us to efficiently send large read-only values to all of the workers. They're stated that the workers could use in one or more Spark operations. It's like sending a large read-only lookup table to all of the nodes. The second shared variable type is accumulators, and they allow us to aggregate values from workers back to the driver. Now, only the driver can access the values of the accumulator. For the tasks, the accumulators are basically write only. And we could use this as an example to count errors that are seen in an RDD across workers.
Sorry, man. My wife is American. She watches all kinds of stuff, and she's left, you know, these guys. Okay, so yeah, that's basically it, guys. Like, we are really pumping through RDD land very fast, I'm afraid, but that's okay, right? You can descend deeper. So here's the summary. Spark automatically creates closures for you. So for functions that run on RDDs at workers, this is done. You just have to use curly braces pretty much and declare the variable you want to ship inside. For any global variables that are used by those workers, this is available. There is one closure per worker is sent with every task, and there's no communication between workers. Closures are one way from the driver to the worker, you know, one-way traffic. And then any changes that you make to the global variables of the workers are not sent to the driver or are not sent to other workers. And we can, of course, the problem with closures, as I said, is that they're automatically created and are sent and resent with every job. So if they're sort of heavyweight, they just clog up traffic. So you need to know when to use broadcast variables and accumulator variables for your designs, right? And usually you won't get into this. Anything we do in this course, I usually already do this for you. But I want you to know that this is kind of the primitives that are being used to come up with some innovation in the machine learning library in Apache Spark, for example, that developers think is worthwhile and they are building. So you kind of need to know what's all the basic recipes that you need to use. But very soon we will leave RDD land, okay, and go to this more safer land of data frames and data sets for efficiency reasons, basically. And also our use cases will not need reinventing anything. I mean, not need creating new stuff. So we will use these higher level APIs into RDDs, okay. So anyway, please watch this video by yourself. So let's see. It's only 30 seconds, right?
So in summary, when you write a Spark program, use the master parameter to specify the number of workers. When you create an RDD, you can specify the number of partitions for that RDD, and Spark will automatically create that RDD spread across the workers. When you perform transformations and actions that use functions, Spark will automatically push a closure containing that function to the worker so that it can run at the workers.
Okay, so that's basically, here's homework. Okay, I don't know, you can see notebook numbers may be wrong, let's see. So yeah, so there's a bit of homework. There are other notebooks after this. So how would you import Scala and Java libraries? This is kind of the next main thing you need to know. Is say Scala math library. So you can do this, import scala.math._. And now the minimum function is available for you, right? So you can, for example, use the hash map in Java utils. You import Java util hash map, and then you can start using the Java hash map as in pure Scala code. You just use new hash map, specify that it's a hash map or the keys, a string, values, and int. So this is the constructor, the default constructor for Java. So anyway, this gives you a map. Now you can start using pure Java methods like map.put, AB, B2, C3, E4. So all of Java's under your hood right there, right? That's what I was saying. Scala people love it because it's just, a faster way it's just a very convenient way to reach Java libraries. Okay, so this is homework. Okay, so what I would like you to do is basically kind of go through this. And I've written a lot of stuff, things that I tripped and fell that I think are actually good to know. So even if it's good reading about it. We're just creating an RDD here from 0 to 1 million. And here's just taking 5, so it's just going to reinforce notions for you, right? Just don't go and click. I mean, understand stuff, right? I really don't have the time to say stuff like this. Hide code, and then I can say stuff like person MD, create and whatever, create the code that generated the output. I mean, you know what I mean. I don't want to do this just because it's a very mixed audience. We have people from industry, we have students, so I don't want to turn this into an auto-graded assignment, okay? So yes, all the solution is there, but just try to go through this slowly. Okay. So yeah, I should say something like can you create an array by taking the first 5 elements of RDD 0 underscore 1 1 2 3 4 5 6 dot. Okay, I don't want to do this type of stuff, right? So you understand this for you as an exercise, and yeah, so knock yourself out. You know, here is the ordering reverse thing. So if you want to take ordered and reverse the order, so there's a lot of syntactic sugar that you will need later on. Just be aware of where the syntax is a good idea. Yeah, what else is interesting here? So I'm doing some multiplications. Yeah, it's just revisiting the same ideas with slightly different examples. So it sort of reinforces. Okay, this is actually, yeah, that's what I was looking for. So you need to know the limits of your numeric types, right? Because someone's asking earlier. So let's actually ask what is the minimum value of int and what is the maximum value of int, right, in Scala. So int is, what is it? 2,147,483,648, right? So, well, that's a finite number. Okay, so we need to know the limits of our number screen. So when we start doing like multiplications of some long list and it's all positive, it's going to run out, right? So, and I don't know, you know, you need to, and depending on the arithmetic implementations on the language and the library, you know, in some cases it just does modularly, it comes back. So you need to know what the limits are, right? Long is the long integer, which is really much long, much bigger. I'm not going to try to say this, but this is basically all the milliseconds that have happened since, when does clock time start? Oh, 1970, right? Is it? Yeah, so anyway. So this is much bigger. And in fact, long is the default, is the default return type for the count of an RDD, like how many elements are there. So okay, so yeah, I think this example is just trying to show that we have overflow out of the ints in a circle back to negative ints, because here it's doing it modularly, right? So I'm just taking a range of numbers from 1 to 21, and all I'm doing is taking consecutive products. And so by multiplying numbers from 1 to 21 consecutively, I've gone to negative 21, blah, 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 right? It's because multiplication on ints in Scala is modular, right? It makes a big ring of the positive and negatives. So, yeah. Same with longs, I guess. Yeah, well, for 1 to 21. But see, by putting capital L, this is like type inference. Now it knows that this is not an integer, it's a long. Okay. So, okay, let's make this a bit slower. So let's say val my long is equal to 1L. So it'll know that this is long. Long is actually a long integer, right? So remember, if I say my long equals 1, it's going to infer that to be integer type, you know. So this is one way to do it, or you can put colon long and explicitly set it. So so that's what I'm doing here. Oh, sorry, so I should probably move this guy down. That's what I'm doing here by putting 1L to 2L, so it'll give me a list of long integer types. And then now I'm applying the same reduce that I did here. And longs are good enough to do this multiplication. But of course, if I increase this to a few hundred, I don't know, it might come back around. So, I mean, we'll visit these ideas in a lot of detail in the modular arithmetic that's underlying the hood of pseudo-random number generator that kind of the whole world revolves around, called the Mersenne twister, right? These things can matter if you just want to do simulation to solve every problem in the world. There's some number theoretic issues you will need to be aware of, maybe. For the Mersenne twistor, it's called the equidistributivity condition. It breaks down in 6,243 dimensions or something. Anyway, for this course, it doesn't matter, right? But simulations have number theoretic limits that you need to be aware of. Oh yeah, so I did this. Okay, so of course. So if I go from 1 to 61, I already come out through the negative side of long. So yeah, that's kind of silly, right? 1 times, 2 times, 3 times. Boom. So anyway, let's yeah. So this is again, yeah. So this is interesting because I guess it hits. Yeah, I don't know what's going on here. So Anna, do you know? So I'm trying to, I'm getting 0. So I'm running the same code as above, except now I'm going to, instead of 61, 1 to 61, I'm going from 1 to 100. Do you think I must be hitting 0 in the modular multiplication and I pick up the 0? Anyway, I don't know. Okay. See, because 62, it's kind of interesting, right? It's going from negative to, anyway, I don't want to. So strange things can happen, and it's because, yeah, something else is going on in the machine. Okay, let's do a bunch of transformations to RDDs. I think I'm going to let you guys play with this. So now I'm coupling them together, right? So we parallelize, we make an RDD, we filter that RDD, and then we map again and reduce again. So this is chaining all these maps and functions. So this, you want to get comfortable with these things, right? For other things like distinct and flat map and okay, so okay, that's kind of your homework in a high speed. So now let's do something interesting with data, right? Before we cut. And so this is the word count on the U.S. State of the Union addresses of presidents. So we're going to basically do our word count example. So what we need to do, I guess we already did this. We created a Scalable Data Science folder. Right. So what we want to do is copy this URL, copy link address, and then we go to the workspace. And so then you want to go here and import. Let's see. Yeah. You want to import and OURL and Control V. So it's just another DBC archive that's there. So if you do this, you should get a bunch of extra resources. And okay, like a folder like this. Okay, so it basically, you know, it's a bunch of programming guides, sort of Markdown and Databricks guide. And I think, oh yeah, SDS datasets. So what I wanted to show you here is this notebook here in extra resources called Scraper for US State of Union addresses. So this is not like a proper data engineering, robust, scalable way to do it, but it's just a few text files, so we can do this. To do this properly, there is something called Apache NIFI, which is also an NSA project. So, okay, so this is actually a more systematic way of ingesting data at scale in a kind of a fault-tolerant, robust way. With yeah, so this is actually one of the NSA open source ones. Well, we don't need Apache NiFi for this. If we are going to ingest the global GDELT streams, which is something we'll at least play with a little bit in the course, just for one 15-minute window. But if you want to ingest the entire globe's news feeds from print and radio, whatever, everything in text and translated, then you would need NiFi, right? Because it's quite a serious job and you need it to be robust. But this is enough for us. So what's been done here? Sorry, too many things. I have no idea. Give me one sec. Okay, where are we? Oh well. So let's go here. Scalable data science, extra resources, and support. Oh yeah, sorry. Screwed everything up. So, yeah, it's this one, right? I mean, we don't need to do this, but I want to show you what was done, right? So, so it's basically, this is the shell command. So we have a web page called HTTP State of the Union. Okay, so this is basically the web page, and so if we go to this web page, so someone has been collecting the US State of the Unions here, right? And we just basically are mining it using very low-level shell scripts. So we want to basically get this text file, and this text file has some HTML content, and so we want to do this. We want to extract them, and that's what this this bash is doing, right? So there's this is basically the bash %sh, and you could run this. It may or may not work because I haven't tried it since a few months ago, and right. So it's basically yeah, so if I, now I have this for loop in bash, so, and links is actually a reader, a text web browser, and I'm asking it to dump this, and then I'm typing this, so these are sort of bash pipe symbols, so you take the output of one program, pass it to the other program, and then I'm piping into a program called grep, and so remember, you guys can always do this. So you can figure out what each of these commands mean and stuff. I mean, I don't expect you to do this, but just to show that this is not black magic. And then, you can grep for the occurrence of the word text and then pipe that into grep for the non-occurrence of index. And SED is a stream editor, and there's some substitutions being done. So anyway, at the end of the day, we basically get some text, okay? And this is okay to hack like this for small data sets, but we want to use something more robust. Okay, so now once this is done, what this would basically do is get the data for you. So I'm basically asking pwd is print working directory. So this is basically a very important command. So it tells you what the current directory is that you're in. So this is the directory is Databricks driver. That's the name of the directory, right? And then and is execute the print working directory command, and then execute the ls command, which is list what's in that directory. So now it says there are files called conf, derby.log, event logs, ganglia, and logs, whatever that come with it. Now I'm asking it to show how much space there is, disk, user, summary, human. So it's 17 MB. So I just kind of trying to see how much space there is so I can pull things from the web, right? So we'll do these kinds of things here and there as we need special data from here and there. So, but there's sort of this basic process behind it. Okay. So let's not get too bogged away. So once I get all of this, it's yeah. So I think for you guys, the fastest way to go here is, let me see. So let's go to, yeah. So because what we need is we need to get this data that's already pre-processed for you. So let me see where we can do that. Okay, so right. So yes, so we have to do it here. So what I want you to do is a whole bunch of stuff was done and processed, and I put that in this nice folder called sou.tgz. It's my home domain, lamastex.org. So all you need to do is to run command 11, right? So I'm using a program called wget, and wget is basically pulling this file sou.tgz that was processed using these commands above. Okay, this leaks and blah blah blah, and it basically, yeah. So now I don't want you guys to do all this because you may have to install leaks and missing things in your system. So we'll just grab this data. So now if you do %shls, so this is the second command you really want to run, you will see this thing called sou.tgz. You guys see this? Okay. So now all we have to do is, let's see, we really need to, yeah. Yeah, so if you're in doubt, you can do %shenv, so it'll give you all the environment variables. So for example, I know my shell is bin bash. This may help later. So now the next thing we want to do is tar. So these are options to tar. Z is compress, X is extract, V is verbose, F is file. So I'm basically asking it to extract sou.tgz. Okay. So now if I, so I've extracted it. So now if I do ls, what I'll see is a new directory called sou, because sou.tgz was archived with files inside a directory called sou. So when I deflate it, I have sou. So what I'm next doing is changing the directory into sou and listing its contents. Okay. So is everybody here? You should start seeing these text files. 1790 January 8th.txt.
Not really.
No? Yeah, so let's
There's just two commands to run, right? There's just two commands to run, the trigger and then.
yeah, basically all you need is So you need to run this command, which is command 11, and only once. And then all you need is this command. You have to extract it. And then, and then this is just to see if all the files you extracted is there.
Can you show the tar?
Yeah. So the tar one, yeah. So this is, this one. Yeah, I kind of purposely didn't give you just those two commands because I thought that was like amazing. So you got it right? Yeah. Did you do the CD, SOU, and then LS? Yeah, so you doubly got it. So now you see SOU.tgz, right? Okay, just yes, that then yeah, so that's the tar ext and that's the extraction, right? And then the next cell, you enter that. No, the other one that's yeah, that should be.
So these are my.
Yeah, so that worked, right?
Oh, okay.
Yeah, so you have all the text files now. All right. So okay, so now we're going to head is a bash command that lets you see the head of the file, just the starting. And I'm asking it to show me head of the file 17900.108.txt. And this is now the text, right? George Washington, January 8, 1790, fellow citizens of the Senate and House of Representatives, blah, blah. Okay? And I can also see the tail of the file, right? So this is just what's the bottom of that same file. And yeah, so this is the bottom, it's sort of free, efficient, and equal government. It's the end of the speech. Okay, so I don't know, this is Barack Obama, and so on. Good, so now we have a bunch of these files. What we next need to do is these files are, see, in the local file system of the driver, right? It's not in a distributed file system. It's sitting in the local file system of the driver. So we need to inject this or load this into the DBFS, the distributed file system, which is fault tolerant, blah, blah, blah. So how do we do that? So that's kind of our next main goal. So first you want to, this is a DB utils is a Databricks utilities.filesystem command. So, and DBFS is Databricks file system. It's their distributed file system, which is really here a wrapper on Amazon's S3, right? So if you do this, you will see a bunch of directories or files that are at the root of your distributed file system. It won't be the same as what I see because I have a lot more stuff I made up. Okay, so you should see something. So now, do you have a directory called dbfs/datasets? Okay. So then what we want to do is to make this directory, right? dbutils, dbutils.fs. So let's first hit help, okay? dbutils fs help. So let's sort of look at the basic commands in this, right? This is our distributed file system stuff. So there is copy, right? This is a copy command. Copies a file from a directory across file systems. Head ls make dirs. So this is something that is going to make directories for us. And there's move, put, and remove, and mount, and so on. So we're going to actually do make dirs, right? So mkdirs. Okay, and I want this to be, what did I want it to be? Yeah, I want it to be this one. Okay, dbfs :/datasets. And you should get boolean equals true. Okay, yeah? Oh, is it getting too small? Yeah, good. So all I've done is this. Can you see it now? Or should I make it? Yeah, dbutils/fs mkdirs, make directories, and just datasets. Okay, so that's gonna where we're gonna put our own datasets we grabbed from various places. Yeah. Yeah. Okay, so but we have Databricks datasets, but we don't have anything called datasets. So that's unique to run that command. Yeah. So now you need dbutils.fs. So because you see, guys, there is already a directory called Databricks minus datasets there, right? So that's Databricks' training. We will tap into that as well. That has a bunch of stuff on movie recommendation and Wikipedia clicks and all kinds of stuff. But we also want to create our own directory so we know how to, inject our own stuff, right? So is everyone okay? Good. So then, so now if you do this, there will be nothing for you usually, I have a whole bunch of stuff. Maybe I should just remove everything. Yeah, why not? So let me dbutils.fs. I think it's rm, right, for remove, and then I say dbfs : datasets, and then I have to say recurse equals true, I think. So this basically says keep recursing into all the subdirectories. And do I really want to do this? Oh well, why not? So okay, so this is gonna take a bit of yeah. So anyway, you guys can continue. I'll have to wait for mine to delete, and I'll catch up. Yeah. So yeah, if you already have a directory called SOU, then you can remove it first, but you don't have to worry about it. You just want to do this. You're now making another directory in datasets called SOU for State of the Union. So you just want to execute that cell, right? And that's exactly where we're going to dump all our files that are in the SOU directory in the local file system. So that's basically the next step. Oh my God. Okay. So that's basically, so once you created datasets dot, so here's the copy command, okay? So once you've created this directory, you see copying dbutils.fs.cp, but look here, you're saying file, right? So that's the local file system of the driver. So and then this is where we extracted, right? This is the directory, databricks/driver/SOU. So in the local file system to the distributed file system, Databricks file system. And here we just created this directory and this directory. This is how we're going to copy all the files from the local file system to the distributed file system. Okay. Okay. And then if you hit this, it should be, you should see something like that. Right, and the point is the path now is dbfs : datasets SOU . So now we're ready to do business.
It takes some time for the copying, so it's still running.
Yeah, it's actually, yeah, right. I was gonna say something about the copying time. Let me see if my thing died first. Oh yeah, good. So I've removed everything. So let me make there's datasets again. So I'm going to comment that guy and ls. So there should be nothing now for me. I'll tell you something important about why it's slow. And then, yeah, I don't need to worry about this. And I'm going to make that next level. And then, yeah. So next thing is this. Right. So it's taking a long time to copy for many reasons. So this is something you do not want to do with a distributed file system in general. This is called a small files problem. So when you have lots of small files and you stick them into a distributed file system, it's incredibly inefficient because a distributed file system is optimized to take a large file and break it into some 64 MB chunks or whatever, and stick them into the distributed so Hadoop or whatever S3 file system, right? So we're actually doing this very inefficiently, but it's not going to be too bad. It may take a minute or so. We can start a Fika. There is a much better way to do this, and we will do these things when we try to ingest the taxi trajectories over Beijing for a month or the Uber trajectories in a couple of weeks. And there are other ways of doing this. So you can use the Hadoop native zip readers and all sorts of things. But it's okay to, so how many? It's 1 minute. Right? It's not bad. So, so now I think we're all set up to, I guess, have Fika and continue with a State of the Union address, because this is where we should, I guess I'll be next. So make sure that next couple minutes, and if you're not there, please raise your hand so I can try to help you. So you should be able to, there we go. So you should be able to see everything in this notebook. Okay, if you go to Command 7 and can display like this, then we're ready to continue with word count. Okay, and if you're not here, then just raise your hand and I'll try to sort you out. Okay, so should we take a Fika break now? Okay.